So we've taken vectors, we've added them, we've subtracted them, we've even taken numbers like 5 and did the vector times 5. But if I have two vectors, 2, 3, and then 7, negative 5, well, when I add it makes sense. I could just add 2 plus 7 and 3 plus negative 5. When I multiply, there's actually two different ways to multiply. One of them is the dot product. Later on we'll do the cross product, but for now let's just focus on the dot product. When I do it, you have to multiply with a dot for this. That's the notation. So normal numbers, if I do 2 times 3 or 2 times 3, it doesn't really matter. But for vectors, those are two different things. So here, it's very simple. You take your x's and multiply them together. I'll just write them side by side. Then you take the y's and add them or multiply them together, and you add everything together. So 2 times 7, 3 times negative 5, and you add them up. This would be 14 plus negative 15, so that'd be negative 1. So when you multiply by doing a dot product, you're going to get one answer, one number. It's not going to be a vector. Okay, sorry, I was looking at my notes for a second. So for another example here, okay, we could just take the vectors and write them out like this and put a dot product between them. Now if I do that, I multiply my x's together. So negative 3 times 5 would be negative 15. Then I add my y's added together. 5 times 3 is 15. Now when I multiply these two vectors together, it's just 0. Not that bad. Okay, so we're going to scoot on here. Dot product is pretty quick and painless. The reason we have it is because there is a dot product angle formula. So if one of the great things about having vectors is if I know two vectors and they're written in vector form, I can actually figure out the angle between them very, very quickly. So let's say that these are my two angles, or my two vectors. That's my u vector and my v vector. I want to figure out this theta between them. So the formula goes like this. Cosine of theta on one side. On top, we are going to dot product our vectors. And on bottom, we do the magnitude of each of them multiplied together. And it's really not that bad. So let's do an example. Okay, so let's say I have the m vector, and that is 1, 5. And I have the n vector, that is 2, 3. Okay, now if you have kind of a small picture in your head, that'd be 1 over, 5 up. Kind of looks like that. 2 over, 3 up. So two vectors, we're trying to find that angle in between them. That's just a sketch to get an idea of what's happening. Okay, so the first thing we need to do in this formula is figure out the dot product. So I normally lay it out. I write out my dot product. So that's 1 times 2, that's 2. And I add that to 5 times 3. That's 15. And so 2 plus 15, that's 17. Now that is going to go on top. But I still have to figure out the magnitude of m and the magnitude of n. Now this is why we did the trick. We don't want to draw triangles every day or all day. So we're going to do the square root of 1 squared plus 5 squared. And then for the n one, we do the same thing just with 2 squared and 3 squared. So this is going to be 25 plus 1, 26, square root of 26. And that guy will be 4 plus 9, that's the square root of 13. And so now I'm going to take this right here and I'm going to use these numbers, plug them in. So cosine of theta equals, on top the dot product is 17. Now on the bottom the magnitudes are the square root of 26 and the square root of 13. Now I need to find this angle, so I have to cosine inverse. So theta is going to be the cosine inverse of 17 divided by the square root of 26, the square root of 13. Now be careful when you plug this in your calculator all at once. Downstairs, when you have this fraction, you have to do 17 divided by square root 26. You got to close the square root. But guys, you need a parenthesis around your whole downstairs. Yeah. So just make sure the whole basement has a parenthesis around it when you do this. Now, I crunched this number already. I came out with 22.4 degrees. Whoa. And my classroom light just turned out. So I'm going to write a try it problem over here for you guys to see if you can do this. One vector will be 2, or negative 2, negative 2. Let's just call that the u vector. And then we'll have a v vector. Let's call that for 0. So give it a try. Try to find the angle between those two vectors.